Hey guys, thank you for the intro. Let me just talk 1 minute about Socure. Socure, we are a real-time API, identity verification API. So basically what we help financial institution do is typically we're plugging at the top of the funnel on the onboarding experience. We help financial institution solve for what I call the triangle of onboarding, which is, can I accept the good customer? Can I reduce some of the fraud? And then can I also reduce some of the minor review? And we do everything in-house by data science. And so by using data science and machine learning. So what I'm gonna be talking today is on something that I strongly believe on, and it is around how we automate data science by building robots and by building machines that can do the work that we do as data scientists. So at Socure, just at a very high level, we've been able to build a very strong product, which has gained a lot of attention. And so the focus for our company now has shifted. How can we now scale to a level that we can sell these products very fast in a very efficient way? And so the mandate at Socure is really for us to be able to automate as much as possible. And by automation, I am basically saying how do we build robots around the functions that a typical data scientists do to be able to deliver very efficient solutions for the client. I believe that there are 6 pillars in data science. The first pillar is data exploration, followed by feature generation, followed by model training, then model deployment, model governance, and then the real-time monitoring of the scores and models. Yes, we are a real-time system. I do believe it's a completely different beast whenever you build a model and you expose scores and results of a model into a presentation, than making the model actually work in real time very efficiently and delivering the value that we have promised our customers. And so what I'm going to do is speak very high level at each of these pillars, what we've done at Socure, and hopefully this is gonna spark some of the curiosity among you guys as to some of the things that you guys could be doing to be successful. So basically, the challenge around data exploration is how do you really take data and make sense of data? And then how do you really structure structure unstructured data to be able to extract insights? So what we built in-house is actually a machine, an intelligent tool that will reading any data, will structure data, will clean data, will detect what are the data types. Is it a numeric field? Is it a nominal? Is it a categorical? And then it will apply the appropriate statistics for us to be able to infer insights of the data. And obviously, after the insights are generated, these are compiled into a quick PDF that we use for analytics. Why do I pay so much emphasis on the data exploration is around that I do not want or need a data scientist to be doing data exploration work when you guys could build a machine where the data could be just fitting and the actual output and insights that we need from the data could be easily exported. And the data scientists can indeed just focus on the output of the data and how to make any sort of business sense of the data. We've also built a feature generation machine. So what I mean by feature generation is to, now you have the data, you've explored the data, how do you really ensure that this data is suitable to answer the question or the insights that you're looking for? There's techniques around supervised and unsupervised feature engineering, and a big challenge on the feature engineering is for you to be able to stabilize real-time features. What we've done in-house is that we've packaged a a machine into, once it figures out what are the various different data types, we've put together a machine that will start creating interactions on top of the various features to see whether additional features could be extracted. With some of the techniques that we have embedded in the machine here are rule induction, variable clustering, interactions, you actually name it. So not to be very specific, as I can't really share what is our secret sauce, but after all of these features are created, one of the big things to keep in mind is, should we keep adding features even if they don't add value? And so what our machine is able to help us do is quantify the incremental value of that feature. So in other words, I don't believe you should be creating or adding additional data to your frame if it's not adding any value at all. This machine has allowed us to test, for us to test in real time a lot of data sources and be able to determine from our side what are the data sources that are powerful versus non-powerful to be used in our solution. One of the things that we've done in-house as well, and which was very impactful to our business and has allowed us to grow pretty fast, is that there's always a challenge in the model training. Before we developed a machine around the model training, we were stuck into myself and another senior data scientist having to check every other data scientist's work to be able to get a model in front of a client and be able to deploy the model. What we've done on our side is build a machine that allows us to build many models and choose us the final model. So how are we doing it? So in every model training, there's various processes. So there's optimization. So the machine right now, you will input just the training set, and itself, it will optimize on the data engineering. By that I mean, what should be the optimum split between your training and your holdout? It optimizes on the feature selection. I strongly believe that only features that are impactful to what you're trying to solve or the business problem you're trying to solve are the features that should be added to the model for training. So our machine optimizes the features here. It excludes any features that instead of adding value will end up adding noise. It also aligns every machine learning algorithm as to one another and allow them to compete against, to see which one is the most accurate. I don't believe that one single machine learning algorithm is more powerful than others. And so what we've led is let the machine itself and the and optimizations on the hyperparameters dictate as to what is the final model that we deploy into production and that we present to clients. How is the final model chosen? The final model is chosen using various statistical techniques. Whenever we build a fraud-related model, the highly interested metric here, it will be more on the precision, it will be more on the false positive rates, and so we dictate to the machine, hey, choose me the best model that maximizes the precision within 1 or 2%, so that during the onboarding tab of the funnel, clients can use a threshold corresponding to that 1-2% and a straight up decline, allowing them to save large sums of cash. The other thing we've implemented to the machine is we have various different algorithms competing, and then we ensemble a lot of them on top. So if you think about, this is our Socure version of what I've heard throughout the conference on the driverless AI, in where we just throw in data, the machine will run, build models by itself, and then spit out the best model to be deployed into production. Why is this important? Because now I don't have to check on any of my data scientists whether they've selected the variables appropriately, whether they are ranking order the models appropriately or not. Now these are done in an automated fashion, taking away a lot of human potential errors. one of the things that I haven't heard a lot during the conference is how do you take a model that is built either in H2O, Python, or any tool out there and make it deployable, right? The challenge with deploying a model is really to ensure the stability between the development environment and your production environment. How do you take a model from development and ensure that that same accuracy is going to be shown in production in real time? And so a couple of things that we've implemented, it's itself a machine that you throw in a model. It could be a Pojo, it could be an RDS if you're building models in Python. This machine will do an integration test. What is really an integration test? It will take holdout data that was used during the development environment, and it will score it within the production environment. I will give you a head-to-head comparison, ensuring that there is no deviations. Couple of the things that the machine also does is that it verifies that the features are being passed correctly. For example, if you see that a feature that is a numeric or that was built with a numeric encoding 1 or 0 or 1.0.0.0, and then you see it in production that is being passed as a categorical, the H2O tool or any modeling tool would not score that model properly. One of the things to keep in mind in production is that there needs to be alignment between the development and the production environment. And in real time, you have to ensure that the data that's being passed through the model for scoring is indeed aligned with how the model was built, or else a real-time system is going to fail. And then the last piece that we do in-house and that the machine allows us to do is to itself help us within the merge requests in any of the GitLab or GitHub or whatever tool that you guys might be using. So from the model deployment, there's actually a lot of documentation that I haven't heard many of the speakers talk about, and this is around model governance. Not a lot of people are familiar as to what is model governance, what model governance entails, and how do you pass model governance through one of the big financial institutions to be able to have a successful model that they will be decisioning off. What model governance ensures is that the models are empirical, free of bias, and that it meets all of the compliance requirements. There's two, I want to say that what we've created in-house is two levels of model governance, or two pillars within model governance. In order to pass model governance, there needs to be a detailed model framework, and the model framework talks about the purpose of the model, the clear definition of the dependent variable, the clear assumptions and limitation, what will happen in real time if a variable is not being passed? What is the impact to the model performance if, for some reason, some of the variables in real time are being passed as NA? What are the theory behind, like what algorithm was used? Why were certain hyperparameters tuned to the way that they were chosen to? Why the number of trees has an impact into the final model that you choose to go into production? A lot of financial institution also requires a stress testing. By stress testing, it's basically looking at what could be of risky scenarios that could allow the model to degrade over time. They also require challenger models. Why do you choose this model versus other models, and how do you get to data optimization for them to feel comfortable to present in front of regulators? And then the second pillar of the model governance, I'll say in detail, this is more on the production model lifecycle. How do you monitor a model that is in production? How do you refresh the model? When do you know that the model has started to degrade? And how do you go about refreshing the model? Do you simply replace the model without letting your client know? And then the last thing is when is a model ready to be retired. And so at Socure, we keep in mind all of these things, and we we created lots of documentation around it, which has allowed us to, that has made all of our clients comfortable. The last piece that I want to talk about is once the model is in production, what are some of the things to keep in mind to ensure that the model is performing in real time? The challenge with the real-time performance of the model, and especially if you're building a fraud model, is that you do not know the outcome until 30 or 45 days after you've given your client a probability score. So what are some of the things that you could be doing to ensure that the model is stable and that both the client and yourself, you're comfortable with the scores that you're returning? What we've built in-house is a machine that pulls data on an hourly basis out of production. This data pool gets compared head-to-head against the holdout of the training set using various different tests. An example could be the KS test, in where you look at the distribution. If you see that the distribution of the scores that were created during the holdout mimic what you're returning in production, I want to say that you're comfortable that you're returning the right stuff to the client. Another thing that we do in-house is that, as I mentioned, we are a real-time API. We know what are the PIIs or the elements that the clients are passing to us real-time. And by knowing that, it allows us to look at the holdout again and see, are the clients passing in the right information? If they're not passing in the right information, we trigger an alert. After the right information are being passed, it goes through a second level of checks. Are the predictors to the model being properly passed? And if they are not, we trigger an alert. But how do we measure whether they are properly encoded or not? We take a look at, again, the holdout. Your holdout is always going to be the comparison. And when we look at the holdout, we are able to notice right away whether any encoding in the real time has changed, which is going to throw off the model. And then the last piece is really looking at the scores that we return, as I mentioned before, doing KS tests or your proper statistics to ensure that what you're returning is correct. And on top of all of these statistical tests, we've created like a real-time alert. We'll right away know before our clients that there's issues with the data or with the data we're receiving, or there's issues with the variable being passed to the models, or whether there's issues with the scores that we return. So in sum, what we've built here at Socure is we believe in automation. We believe that the next phase of data science is really creating robots that allows people, that allows the robot itself to do the work that data scientists are doing. So Series B funded startup, there's no way we can hire as many data scientists as we would like. The only way really to bring things to the next level as we're doing is by continue to automate. The next step for us might be, now that we have automated the individual 6 pillars of data science, maybe we build on top of these individual ones a robot that will interconnect the 6 of this. And so we freed ourselves and focus more on doing cooler work, as figuring out how to look at data differently and so on. In sum, our robot adds trust to the identity. We still live in an economy that is driven by cash. There's a lot of people that you can't really find records of their identity. And by our robot, we are able to give trust and allow financial institutions to accept more of the good people while declining more of the bad ones. So I'll wrap it up here and open it up to questions, as I know I spoke here very high level, but unfortunately I can't really drill into very specifics. Okay. What if the end-to-end process gets broken due to some severe data issues? So I'm not quite sure what severe data issues are, but I can tell that in our system, we believe that this is not the end product or the end robot. I believe as any robot or product out there, you go ahead and deploy what you currently have in-house, and then you iterate on top of it. If there's any severe data issues that we were not aware of, we should be able to find a solution around it. And so today it has worked, and we have really never seen any severe data issues with what we've built in-house. What industry business problem has it been used for? Can you share a couple of examples? Yes, so today we have top car issuers in where we're trying to help them reduce fraud. We've saved them millions of dollars, both to car issuers as well as to money remittance companies. In real time, we're able to give a probability score as to how likely the clients are, the consumers that they are onboarding in their system are to commit fraud. And we do this in less than 2 seconds. And so it allows our clients to quickly be able to assess as to whether they want to accept or decline the actual transaction or application. Sorry. What are the typical compliance issues? Who gets those guidelines? Is there a formal guidelines? Yes, so the typical compliance issues are around how do we handle PIIs? How do we go about ensuring that, one, we're able to tokenize the PIIs into a completely different data warehouse? There's no reason for us to use any PIIs in the predictive models. It just doesn't make sense, as what we use in our predictive models are patterns or features are built on top of the PIIs. In terms of the KYC, we do have a KYC solution itself, and so we are compliant, and we've done all of the checks there. How do you handle the trade-off between? Can you add an external visualization tool? Yeah. So right now, we haven't really published all of the work. I think at Socure, we've been focused head down into how can we build a product that's better out there than anything that the fraud industry has seen before. There's going to be opportunity of us to be sharing some of it and potentially building a GUI on top of it, but right now we don't see the need as it's being used internally, and actually 1/3 of our company are all data scientists. How do you handle the trade-off? Okay. So how do you handle the trade-off between model complexity and business intuition? How might this differ between sectors? Yes, actually that's a very good question. So a lot of my work as a VP of data science is meeting clients and explaining results to clients. We find that industry to industry varies. Even big financial institution, the car side line of business might be more advanced or have completely different intuition around what we're doing versus the deposit or DDA side of things. And so there's a learning curve. There's a lot of explaining to do. There's a lot of adding a dollar value to the analysis or models that we're bringing to the solution. For example, when we go ahead and suggest, hey, use this threshold is going to save you, is going to capture 60 or 65% of your overall fraud. We have to explain why that threshold was chosen, but also explain what is the monetary value associated with reducing 60 or 65% fraud, and that's going to spark the curiosity of not only the technical folks on our client side, but also the business. How do you define your validation set labels? When do you auto-test your models? Do you treat consumer labels as definite truth? Actually, that's a very good question. So one of the challenges we're seeing industry to industry, clients by clients, is that there's no consistency in how they're labeling their bot population. By that I mean, for some financial institution, what is defined as bad is not bad for another. And so there's inconsistency as to how the fraud teams internally are defining fraud or how they define the bot population. In terms of what we're doing, no, we do not trust any of the labels until we see things running in production and we see that there's consistency in labeling data from our clients.